Good morning, everybody, or good afternoon, whenever it's the time that you're watching this video. We're going to continue with the fourth installation of the video of our videos on how to build REST API with Phalcon version 6. We did a lot of work. We changed a lot of things, created an env manager, created an action handler to handle all of our actions, worked on the container, and did some work with tests in the last video. In this video, we're going to continue our work, and we're going to introduce middleware, different services, responses, and definitely tests and PHPStan. So let's keep our code as clean as possible. This is something that you should, let's face it, we always get sucked into building the code as fast as we can, but we should be looking at PHPCS code sniffer as well as PHPStan to see to monitor how our code is doing and whether we have certain things that are not 100% as they should be. We're going to get into our environment and run code sniffer now, and also PHPStan. Alright, no problems with code sniffer. And PHPStan gives us 11 errors. Reminder that Composer CS and Composer Analyze are Composer scripts that we created just to ensure that we just type one thing and we don't have to remember the whole syntax of the command. So code sniffer complains about certain things. It doesn't know, for instance, in this one, the first one, adapter interface parameter options, it's this one. It doesn't really know what this is. It's just an array. But PHPStan in its max setting, max analysis, requires us that we define what these arrays are. And although it doesn't affect our code at all, PHP will accept an array whether it has a doc block or not, defining what that is. It does help us understand what data is being passed into our methods and what data we get back from our methods. Now, disclaimer here, I'm not an expert on PHPStan. I have a lot of work to do to learn a lot more. This is what I managed to do in order to get this thing to work the way we want to. So please be gentle. Now, what we're going to do is we're going to create a new class, and we're going to name that env manager types. And this is going to be an empty class. I don't want anything in it. It's going to be a final class. And in here, we're going to define PHPStan templates so that we can import them in the necessary areas or files that we need to. This way, you don't define types twice, and also you have one area where you can go and inspect your types the way they are. And don't worry, this file will just be sitting there on your production environment or even your development environment, and it's only invoked when PHPStan is running. So this is kind of like a dead file for us, but it gives us a lot of information. Another implementation would be to create an interface. Some people might do that. I just prefer classes. So we have one adapter, it's the .env adapter, and if you recall, this .env adapter expects a file path. So this load array options expects a file path. So in our types, rather, we're going to define this array, how it should be. So PHPStan type, well, let's call it t.env options. For these names, some people use snake case, some people use camel case, whatever. I prefer to put a T in front of them so that I know it's a PHPStan template. It's entirely up to you how you want to name those types for PHPStan. So for the .env options, it will be an array of, it will have file path, and it will be a string, but we're going to put a question mark here because if you notice, we are checking if the file path exists or not. So here you might have the file path or not, and here we're just setting it to null if it doesn't exist. So it's an optional thing here. Also, we're going to create another PHPStan type, and that one will be T options, and these are the options, how they're being set in the env. You're going to see exactly where we're going to use this, and it will be array string, and it will have either an int or a string. And the final one is the PHPStan type T settings, and these are the settings that are that we hold in the env manager. This is the outcome that vlucas's.env library has produced for us after reading the env file. So that will be an array of a string, and then the value would be either a boolean, integer, string, or null. Alright, so now that we have this this types method or class rather, let's go to the adapter interface, and the adapter interface will need to have a doc block here to define. We have already our types, so let's import them here so that we can use them. So we use PHPStan import type, and we're gonna import the t.env options from env manager types. So now you see the usage of this class. We're just importing different types, and then we're gonna import also the settings. Yes, the settings. So our load, this array will be a t.env options, and this array that it will return, it will be a t settings, because the load on the adapter, on the .env adapter, invokes the vlucas's .env, and as such it picks everything up and it gives us a settings array back, right? So yeah, we just defined those options. So let's have a look. This one was complaining for 2 errors, and now we have 13 errors. Excellent. Even more. T.env options does not exist. It's this one here. This is correct. It's the same name. Okay, it's my fat fingers. It's not EVN options, it's ENV options. So I'll have to correct it on the other ones. There you go. So now if I run it, I have 10 errors. Okay, now it complains about the .env because the adapter interface is done. Let's go to the .env file, and we're going to do pretty much the same thing. Actually, let me copy this because we're going to need it. So in the .env file, I'm going to drop this box here and import the files. And now, as with the other one, this one is t.env options. What it's going to return is t settings. And yeah, so far so good. Let's run this. We have 10 errors, now we have 9. And again, we have .env, it says should return array string boolean blah blah blah, it returns array mixed. So in order for us to fix this, we're going to have to instruct, we're going to have to tell PHPStan what is being returned. So the I don't know if this is the best way to do it, but this is the way I found out that it's the how I could do it. So env equals this, and then you throw a t settings on that, and then you return env. Now PHPStorm and others will complain about this. They will just tell you don't assign it to a local variable, just return it straight up. But as I said, I haven't found a better way to do this. For now, this one will work. I don't think it is a significant performance loss to just do this, but you know, it's a little bit of a balance, win and lose for some things. So if we go analyze, we should be down to 8 errors. Yay! Alright, we have the env factory. Let's have a look at the env factory, what we need to do. It complains that the instances type has no value specified. Okay, so we need to put a value here, and our instances will be a string, and then adapter interface. So this is the factory that creates these adapters, in our case just the .dnv, and the instances holds the instantiated object, so that it can give you the object again at the same time. This acts as a cached version or a mapper version. So it will return to you exactly what you need to do. Also, it says here method new instance should return adapter interface returns mixed. This is because we haven't put this one there, so PHPStan doesn't know what this instance's name is, what that one holds. So if we run it again, we have 6 errors, and you see the env factory has only one thing remaining, which will be the get adapters. So get adapters, we need to know what it will return. PHPStorm returns that, the class string. Well, I like to do it a little bit differently. It's an array of string and then class string, like this. So this is the string and this is the class string. So now we should have 5 errors in theory. Oh, yeah. And now we only have the env manager, what we need to correct in there. And in the env manager, reminder, we're storing everything in here in the t settings, and we already have a type for that. So PHPStan import type t settings from env manager types, and then this one will be, it's not a var of array, it's a t settings array. So now if we run this, we should have less errors, which is fine. Now it complains line 57, which is this one. It says that the new instance should be, what it says here, parameter name of method and factory new instance expects string mixed given. So this one here, the adapter, and then let's have a look. Alright, let's start adding some doc blocks here. It will make it easier. Alright, so that's a string. This one returns those. This one is void. And the options is an, alright. So we need to return the options. Whenever there's an array, it's always a dead giveaway that we need to define it for PHPStan. So this one will be an array of string and string. And then if we run this again, it will give us 2 errors because once we added this in here, it understood certain things that that it needs to understand in order to get this thing to run. So now let's have a look. What we need to do is we need to define what this one is. So 74 and 96. So 74 is this one. It says get options should return array string string, returns array string mixed. Maybe yes. Okay. So PHPStan doesn't know what this is, what we get from the environment. So we have to tell it. In order to tell it, we have to put a variable up here that will say string. And then the same thing with this. So now PHPStan knows that this is a string definitely and this is a string definitely. As such, this definition array string string is working. So if we run this again, we have only one error. So the only thing that says static blah 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 does not accept mixed in line 74. And this is the line 74, and we can do here that the options will be T settings, and also the ENVS will be T settings. So whatever comes in here in the array map, it will be a T. Whatever comes from the array map, it will be a T settings. When we run it, no errors. So there's our PHPStan. And this is how you do run this, slowly going through the code and all that in order to make it so that you have no errors. It is a little bit tedious. For some, it would be a lot more time consuming, and some might even think that it's useless. But the one time that PHPStan will complain that this array is wrong or this interface is wrong, it is going to identify a bug that could cost you later on hours of searching or problems with your customers. So it's a good practice to code a little, do PHPStan, write tests, then code a little, do PHPStan, write tests, and so on and so forth. Okay, so after this, let's commit these things. Yep, let's put all of them in and just write PHPStan corrections. Okay, now let's go back to our index. Traditionally, you would want to have your entry point not to be clogged by a lot of code. I have seen applications that in the index.php they have thousands of lines of code, and that makes it difficult for you to identify where any potential issue is. But if you structure your code into different blocks where you can identify each and every one of them, then it makes it a lot easier. As you saw here in the index.php, we create our container and our application, we set up our routes, we set up some hook points, and then in the end we handle the request. So let's move this code here, the routing part, to a different class. And in order for us to move it to a different class, clearly we're going to have to create some sort of a provider that we can invoke with the DI container. This is a feature that we're going to check in a little bit. And of course, we're going to discuss why that feature is preferred that way versus setting everything in the container itself. But the point is that we need to set up our routes, and we need to make sure that the setup is flexible enough so that we can add as many routes as we want. What we're going to do is we're going to use an enumeration to help us with it. For those that haven't worked with enumerations, it's a new thing in PHP, and you have backed enumerations and that return a type or none or whatever. But for our purposes, enumerations we're going to help us define the routes and return to us what each route should do. So what we're going to do is we're going to create a new folder under services called providers, and this one refers to the providers of the DI, their registration instructions for the DI. So what we're going to do is we're going to create a new file called routes enum. Let me copy the doc block, just throw it in here. It's not services providers, and this one will be enum. That one will be a string. And also what we need to do is, because we're going to use this significantly in the project, we need to create an interface for this. So our interface will be called routes interface. Actually, let me copy one of them here. And the routes interface, what it's going to do is it's going to extend backed enum. This one comes from the enumeration. What we're going to do is we're going to define some constants here that would allow us to register different middleware, different endpoints, and so on and so forth. So public const delete will be delete, get. No, we're not going to do head for now. We're going to do post and then put. And also what we need to do is public const event before and after, and it's not route, it's actually finish. And actually we're not going to need the before for now. And what this enumeration would allow us to have is the certain things. So public function endpoint, and that will return a string. And it's good if I can spell endpoint, and that's a string. Then what we need to do is we need to have public function method. That's going to be a string. Public static function middleware. That will be an array. And then public, come on, function service. That will be a string. And in line with PHPStan, let's define what that middleware would be. Interface, and then PHPStan type, let's say T middleware, and that one will be an array. And then the first one will be a string, and then the second part would be either before or finish. And let's dump this one here. So this middleware, what this one will return is it will return a string and then the word before or finish. So it will be either this or this. Now that we have this interface, we need to go back to our enumeration, which is here, and then say implements routes interface, and then we're just gonna add the method stubs. So what do we have at the moment? So in the enumeration we just define its elements. So for us would be case hello get, and that one will be an empty string. And let's add a new option, will be a health. So sometimes we just need a health endpoint, service is running okay. Let's just add it here. So health get, and that one will be health. This one will make sense certainly a little bit later, but these are the endpoints. So imagine them without the slash. So this is just the naked domain like this, and this one is the slash health. We just don't add the slashes because the methods below will actually do what we need to do. So for the method, what we need to do is we need to say, all right, well, what is the method of this? For the hello get, what is your method? Is it a post? Is it a delete? Is it a get? And so on and so forth. In our case, we know because we named it, but the application doesn't. So we have to do this. Note that we have public function here, here, and here, but we have public static function here. These functions, the non-static ones, apply mostly to the element that you're accessing. So once you access the hello get, you're going to be able to access the method on it. So in order for us to know what the method of hello get is, we're going to have to do a return match this, and this refers to whatever is selected or whatever you're manipulating. And in our case, it will be self hello get equals get, and let's put the other one too, because the other one is also so health get, and there you go. So both the hello and the health will return the method get, so that would give us information for our router. For our service, if you remember, we have a hello service in the container. We're going to do the same thing, return match this, and then it will be self hello get, and that one will be container will be hello service. And we do need one for the health. For now, let's put it the same. Health get, so health goes at the top because it's alphabetical. Oh man, should have done this better. Another thing is I try to keep everything alphabetical. It makes searching a lot easier later down the line. So what we also need to do is we need to make sure that whatever we return is something that the router can understand, right? So for now, middleware, we're not going to do anything. Let's do return an empty array. Okay, and it will make sense how how we're setting everything up. Actually, since we do have the response sender, let's add it here. And why not? We do have one middleware that it's running. It's this response sender, and that one runs at the end of every request. So what we're going to do is we're going to say container it's not here. Okay. Anyway, well, let's fix this in a minute. What this enumeration still needs is the endpoints, and let's do a little trick here just to make our endpoints as flexible as possible. We're gonna create a prefix and a suffix. So public function prefix, and that one will return string, and I'll explain why that in a little while. And public function suffix, and that will be a string. So I'm just going to type it here so that you can see. Let's say we have user get 1 2 3 4, and then we might have user list, and so on and so forth. Alright, what I define as prefix is this one here, the very first thing that you get, and suffix is either the word get or the word list. That's how I split it. Now clearly this doesn't cover all the options that one might encounter with URLs, but the prefix is the first thing, and suffix might not exist, it doesn't matter. Or we can just use the prefix as the whole thing and not even define a suffix. But this is the idea of what the prefix and the suffix is. And what I do want also is whenever I have a dash to replace it with a slash. So something like get inactive, like this, will become for the router like this. This is a little technique that I use in case I want to make the URLs a little bit more descriptive for the user. It doesn't mean that you guys have to do that. Your endpoints might be easier or not. So in order for me to do that, what I'm going to do is I'm going to return here first of all the slash. That's why we didn't put it up here in the constants, and then we're going to do str replace, and you're going to replace a dash with this guy, and then this value, and then the suffix would be return this empty. I'm leaving this the suffix there on purpose because we can use it to expand our code later if we need to. And for the endpoint, we're going to return this prefix and then this suffix. Again, not entirely necessary to do it this way. You can do everything in endpoint. I just prefer to do that. It gives me a little bit more flexibility. Now reminder, the endpoint, prefix, and suffix, they all run on the element that you have selected in your enumeration. So if you just say routes enum hello get, then you can run endpoint on it, or prefix on it, or suffix on it. That's why these methods use this. This does not mean the num class, it means whatever you have worked with, whatever you're working with right now. Okay, so one thing to do here for our friend PHPStan, it will be PHPStan import type, and we're going to get the T middleware from routes interface, and this T middleware will be the return for our middleware array here. this. Now let's have a look quickly at the response sender. This is to identify our middleware, and then we're going to come back to create the routes provider. So the provider that will consume this enumeration, and it will do whatever we want to do. So the response sender is here, which is perfectly fine. Since this is going to be a middleware, let's call it an actual middleware. So let's rename this. Yes, let's do that. And we have stuff that we don't need up here. And we just need to go to the container to do some work with where these things are, and also we're going to work on enabling this response sender middleware. In our container, we do not have the response sender middleware defined. Quick reminder, we're using it down here in the application finish. So let's define that in the container. So the container creates it for us, and you will see why we do that in a little while once we start refactoring and utilizing the routes in Enum. So let's create another class here. I would say maybe let's call this services. So hello service, and let's call this responders. And let's see, get service responder JSON. It's a JSON responder. All right. Let's rename this to responder JSON, because it's not only for the hello service, it's gonna be responder JSON. We're gonna rename this here, here, and here. And this is the code coverage report. So this is gonna be our responder. Excellent. These are gonna be our services, and let's do another section here for middleware. And we're gonna go public const middle. There we go. This is our response center, and it's gonna be a simple registration because it's just the class. Let me just put 2 lines here. That, and then that one will be response sender middleware class. Alright, so it's registered now. This is our middleware response sender. This is there. And now in the routes in Enum, this is why we did all this. Well, we can certainly come over and define it in the middleware array. So for this, it's going to be container, and then middleware response sender. And that one, remember the middleware type that we set, it's going to be a string first, and then it will be either the word before or the word finish. So this is a string, and then it will be self event before or event finish, and that will be the event finish. So what we're returning here is a name, the name of the service that we want, and where it will be attached. It will be attached in the finish part. So now that our enumeration is pretty much done for the most part, we need to create the provider. And to create the provider, we have to follow the service provider interface that Phalcon DI offers. So let's copy this file and call it router provider. And clearly it's not going to be an enum, it's going to be a class. Let's get rid of this. Let's get rid of this. Get rid of all of that. The reason I copied it is I'm too lazy to copy all the doc blocks, so it makes it easier. So this one will implement a implements service provider interface from the Phalcon DI. And if I add the method stubs, there's only one register that tells us what to do. Okay, so in the register, we have to figure out how we're going to set up the routes. For now, let's go to our index. And these are our routes here, all the way to the bottom, even the not found. So if we take all this, we can copy it and paste it inside the router provider. Now that we've copied it here, we need to make some alterations. For starters, this application doesn't exist, the method is questionable, and all that. So the DI container is being passed automatically here. What we can do immediately is figure out what where the application is. And since we have the DI container, alright, clearly the application doesn't exist there, so we have to add it in the container. Let's go back to the container and we say public const application equals application. And in order for us to make this work, we need to store the application in it. And the best place to actually store the application is the index.php the minute it's been created. So we have the container, we have the application. All we have to do here is do container set container application equals application. Let's make it shared, and that will ensure that the application is stored into our container. And by doing so, when we come here in this provider, we can actually grab the application again, and that would give us the information that we need a little bit further down. So this is a string. No, actually this is a micro application. That's what it will return. This is a helping doc block for PHPStan. And then what we have is we have the routes here. We have the route pattern, invoke, finish, not found. Great. So we just moved some code from the index.php into this router provider class. So how do we tie those two together? Clearly we're going to have to delete all this thing back, but we need to replace it with something that would do exactly the same thing. So what we're going to do is we're going to create providers, and then providers equals router provider class. So that's all my these are all my providers. And then what we need to do is we need to do a for each provider, and then service equals new provider, and then container register provider. and this one is actually service provider interface. Oops, sorry. This should have been service. And all this can go away. Our code shrinks. So what does this code do? We have an array of different providers, and we're iterating through it. These are just classes. Using the DI container service provider interface, we're instantiating the provider class, and then we're telling the DI container to register that. What the container will do is it will take the class, this one here, and then it will call register on it by also injecting itself into it, and then it will do whatever we need here. And by doing this, we're pretty much setting up the routes. We could have used this methodology to register every single service in our application instead of defining them all here. We're using a mix right now because most of the services are very, very simple, as you very well have seen. The request, the response, these are very simple services. You don't need a lot of setup. But if we wanted to have a significant setup for our service, we could have used the service provider interface, and that's what we're doing with this router provider. Now if we go back to our code, we should be able to see something coming back, and we do. That means that we move the routes into the router provider and everything is working just fine because we have registered the same thing in our application. So let's have a quick look how we can now use the enumeration that we created, how this ties with what we need to do. All right, we still have the register here, and then what we need to do is we need to figure out how we're going to do this. Now bear in mind, setting up the routes in a DI in a micro Phalcon micro application, you can go two ways. One is to set it with collections and mount points, and the other one is to set them directly in the class. So for instance, here what we're doing in these routes, we're figuring out what the method is, which is this get, and then we're calling application method, which is get, and then we're defining the anonymous function on the pattern that you want. There's a different way of doing this, and it does offer benefits, and but of course it has its drawbacks as well. This way of doing things is a little bit faster, but the collection offers a lot more flexibility. Now, in order for us to actually start using these collections and everything in the middleware, we have to have an events manager, because all of these things that are hitting, especially middleware. So if we want to use this as a middleware, we need to have an events manager that will fire and allow everything to work as expected. So it's very easy to do. All we have to do is just come back to our container and just set the events manager as normal. Now note that this one does exist, I believe, in the factory default, but we decided that we don't want to do this. We want to set up the services ourselves. It makes it a little bit easier to understand for those that are not 100% sure with how things are being set up in a Phalcon application. So what we're going to do is we're going to say public const events manager equals events manager string, and then we're going to have it somewhere here, I would say, and then equals this get service events manager. Let's copy this, and then down here it will be so EVM equals new manager, and it will be the events one. I'm gonna put an alias on this, and then EVM enable priorities equals true, return EVM. I could have used the array format with the call, so in the arguments and the types and all that stuff. I could have used, let me shrink this a little bit. I could have used the class name would have been the events manager. The arguments would have been pretty much none, but the call, meaning create this object and then call this method, would have been enable priorities, and the parameters on that call, and that the parameters on the method of that call would have been true, and that would have returned the EVM. It's another different way of doing it. I'm just doing it with a callable here, a function, anonymous function, so it works perfectly fine. So now that we have our events manager registered here, all we need to go is back to the provider and start setting things up so that we can have the middleware working for us. Now, okay, so we need to get the events manager here because we will need it in order to register the rest of the stuff that we need to register. So, let's do events manager equals container get shared container events manager, and then that one will be manager this, and then I need to put an alias. Alright, so now we have the events manager. Now these routes here are going to come from the enumeration. So what we need to do is we need to say around here this attach routes. Okay, and then let's comment this out for a minute, and then make a private function attach routes, and that will be a void, and actually let's pass the application in there, and then we'll have micro application, and this one attaches so what we're gonna do is, first and foremost, the responder here, I don't know if you can see it a little bit, let me just uncomment it so you can see it better. The responder here is responder JSON, right? So we need to get that, and then we're gonna work on setting up all the routes that we need for our application. So responder equals application get service container responder JSON. So this is our responder, and it will be a responder interface, what it will be returned. Now what we need to do is we need to do all these registrations here. this part. Let me just uncomment it so that you can see it. This part here. So how are we going to do this registration? We have a for each, right? So let me copy this and go further down and just paste it and see how we're gonna change it. For us now, the routes enum is the one driving this. We don't have an array anymore. So let's call this. Now, and this one will be an array of routes interface. So every enumeration, in order for you to iterate through it, you can use the cases. Cases is all the elements that you do. So if I want to do for each here, cases as case. And now, what do we have here? What do we need? We need to find the method, pattern, service, and responder. Responder, we already have it. It's up here. It's going to be that responder. We're not going to change it. So we need to find the service, the pattern, and the method. All right. So service name equals case. And you see here now the method service, the method endpoint, and the method. Those were the public methods that we defined in the enumeration. And if you recall, they work on the selected item that you're working on in the enumeration. So for this for each loop, the case is one element of the enumeration, and the service name, the $service name, will become whatever the case service returns, which will be a string. And also what we need to do now is we need to create a new collection. That's a micro collection that will allow us to attach this into the DI, into the micro, in the micro application, so that then it can actually run the routes as a whole. It's a different way of doing it. It's not doing the method part, so application get. It does it by using a collection. Equals new collection, and it's the MVC micro one. So now what we need to do is we need to get the service. Equals application get service and service name, and that one will be a domain interface. I'll come back to this. Give me just one moment. I will explain because I understand this might be moving too fast. And then of course we need the handler. What will handle this? And it's the action handler, and that's not the, it's the responder. All right, let's pause for a second and look at what we have here. And I'm going to have both snippets of code here so that we can understand. First and foremost, up here we're picking up the responder from the DI container. If we look at the example further down, this is exactly this line of code where we're getting the responder from the DI container. And I will explain the difference between the two because we did make a change here. The second thing that we're doing is, instead of using this routes array that we had defined, we're picking up the enumeration itself. And the enumeration is what the place where we're defining all of our routes. After that, we're getting the service name, and in our case, let's go back to the routes enum for a sec. Let's say we select the hello get. If you go down to the service, the minute you go hello get, it will return hello service for you. So this here, the service get service, is the same thing as this service name, which came from the array. Then we're making a collection, a new micro collection, which is fine. Then we're grabbing the service from the DI container, which is this line here, And then we're creating a new handler with these two pieces of information, and that is this line here. So all we have to do now is run the invoke on the action handler when we have this particular route matched. So we haven't done much in terms of, there isn't a huge difference here. There is one significant one, and it relates to the responder, which I'm going to come back to that. But in order to put this thing into, to wrap this thing up, meaning to have it run this, what we need to do is we need to set the collection, and the collection then has to be mounted into the application. So the application will match the route, will get into the collection and do what it needs to do, instead of just matching the method and running it there again. So collection, now for the collection we need to first of all set the handler. So what would be the class that would do the work that we need to do? And clearly it's our action handler here. It's the $handler, and we need to set prefix, which is the prefix of the route. Reminder, when we're looking at the routes in Enum, we decided that prefix could very well be the /user, and then the suffix will be the /get, or it could be the whole thing. You can use it any way you want to. If you want to use prefixes for your collections, then you can group your routes into different collections of /user and then get, put, post, whatever, list, or you can just have them all in one go. So what we're going to do here is we're going to do for this case prefix. And you know what? I really don't like this case. Let's rename it to routes. Let's rename everything to routes because it is easier to understand. So routes here, routes here, routes here, and then this one should become route. So this makes it more readable for us. There you go. That's much better. So for all these routes, as route, and then do whatever we need. So set prefix route prefix, and then what we need to do is we need to tie it to whatever it is. So we need to tie it to the method. This is the same thing as this part here. So this method. So in our case, it will be route, come on, method, and then what it will run will be the route suffix, and then it will run the invoke command. Alright, let's explain that a little bit. This one works, right? Okay. Suffix is nothing. Prefix is what we have. In our case, it will be either the slash, or when we do get this health, it will be the /health. We forgot something. There we go. Alright, let's look at the two snippets together. We have routes here, array, different things that we've defined, method, pattern, service, and responder. We have enumeration here. The main difference between the bottom one and the top is that in this array we were able to define the same responder for we were able to define a different responder for each route if we wanted to. In this case, we're defining one responder. That's the major difference between this and that. Since we're going to be responding, since this is going to be an API, we're going to be responding in JSON. So there's no real reason to have a different responder, but there is ample there's ample opportunities for us to utilize the routes in Enum and then attach a responder method here that would allow us to create a different responder later on. So for now, for this, I just took out this functionality, this flexibility from this array to define your own responder for any endpoint, and we're just using one responder. Other than that, this is roughly the same way of doing it. The only difference is that we're using the micro collection instead of attaching everything straight to the application object. Again, this is your service, same as here. The responder is up here. This is your responder. This is the action. We call it handler here. We can use action if you like. Actually, let's use action because it enforces the action action domain responder. And then what we're doing is we're setting it the prefix, which in our case will be slash or slash health or whatever, and then on the method we attach the suffix, which is then nothing, and then we're calling the invoke of that. So whenever this route is matched, the method invoke will be called on the action, which is this action handler, right? So now we've attached these routes. Okay, so we've done this part, and then this part, and now if we uncomment these out and we go back to our application, it's gonna still work if I do blah 404. And actually we need to work a little bit on this, because if you view page source, this is just a printout, it's not a JSON, so we need to work on that. It's not like this, so, and we need everything to be like this. So everything is working as expected, and we also need to make sure that everything is attached to our application as expected, as we want it to. Well, if you recall, in the routes in Enum, we set up the middleware here as this service to be attached to the event finish. In the router provider, right now we have this guy here, where we're just saying on the finish event of the application, just do this. Well, what if we wanted to use the response sender middleware like that, attached directly to the application with just a simple registration, as we did with using the enumeration. This will allow us to create more finish events or more before events or whatever, and it would make everything configurable instead of just replicating this piece of code. So let's do something like this: private function attach middleware, and then of course we're gonna need the micro application. Actually, I'll put it down there, and of course we're gonna need the events manager, because those fire with the events manager. Events manager equals events manager, and then that. So all we need to do is, after we attach the routes, attach middleware, application, and events manager. Okay. Now, in order for us to attach the events in the application, we need to have the middleware, what we need to attach. So we're going to utilize the routes in Enum, middleware equals routes enum, and remember this was a static class, so we can call it, and now we're gonna get do we have this up here? No. We're gonna get a T middleware array back. PHPStan import type T middleware from routes interface, and we're just helping PHPStan understand that this is gonna be a string as a key, and then the value would be either before or finish. We're going to do a for each, and it's not going to be middleware class, it's going to be service. That's what the key was storing. Method. Whoops, sorry. And now that we have that, what we can do is alright, we need the container, so we need to get the instance equals application get service, and then service. Now we're going to utilize the events manager to attach this class, which is instance, to the micro application, and then attach it to the actual application itself. So it's a two-way process. Attach. Now it's gonna be in the micro, and then it will be instance, and then we have application $method, and then instance. Okay, so here's how this works. It's a little bit weird, but that's how it works. We need this response sender middleware to be attached to our class. If you recall, we did the finish part. Where is it? We're doing this. So in the finish event, we're just saying you're gonna create the response sender middleware, and then you're going to call the invoke with the response. That's what you're doing. That's what you need to do when you finish. When we attach the middleware this way, forget the loop for instance, we're pretty much coming over and we're just saying, all right, give me the instance of this service, and the service would be for this class, right? So we're going to create that class. Then it doesn't matter which order we're doing it, but then what you're going to do is you're going to attach this class to the micro hook of our events manager. So the micro application, this is a keyword and a special hook point for the events manager. The micro application will be aware of this class, that it's waiting there and it's listening, so to speak. So whenever the application now registers this instance, because it's exactly the same instance, it will be able to fire any events for this instance throughout the application for our endpoint, right? For whatever we need to run. In this case, it will be a finish event. So this is how we register the middleware. The events manager is essential for you to get the middleware to work. If you don't have an events manager, middleware does not work. All right, let's put that in there. So now if we get rid of the finish here, I don't expect it to work. Exactly. So it says uncaught type blah 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 invoke argument 1. Well, okay, we just need to make a few alterations. So for starters, the response sender middleware is a middleware that is Phalcon based. let me put it this way. Let me revert. This was just a simple class that we had it there. We put it into a folder called middleware, and we just called it that. It was receiving the response interface or the response, and then it was just sending the response back. Now, if we want to translate this to the Phalcon middleware, we have to change the signature, and of course we have to use utilize an interface. Bear in mind again, I mentioned this in a previous video, that the middleware that Phalcon uses are not the same as the BSR15 middleware. We are going to try and get that going at some point, but for now it's not there. So this is just the Phalcon implementation, and this is how we work with this. So in order for us to make this a middleware, for starters, let's create an abstract class, which will be, let's say, abstract middleware, and that will be abstract. Oops. And then get rid of that. Implements middleware interface, and that's pretty much it. And now our response sender middleware, the one below it, needs to extends abstract middleware. And now we need here to have the same signature, so let's add the stubs. Oops. And the stub is call, and it passes the application. So this invoke is going to change a little bit. What we're going to need to do, we're not going to pass the response, we're going to get it from the application. Container is this one, response, and that one is response where is it? This one. And all we'll have to do is response send and return true. Probably this is for the read only. Yeah. Okay, so let's check the read only out. Okay, so this is now the syntax for a Phalcon based middleware. It uses the method call, and let's redo this, make sure that there we go. Okay, so the middleware for Phalcon utilizes this call method, and it passes the application in it. And whatever you want to do in the middleware, that's perfectly fine, so long as you return a true or a false that can be picked up by different points of the application. In certain cases, if you return false, the execution will stop, but not in all cases. So what we had before was we were getting the response injected into this class. Now we're just picking it up from the DI container, and we're just sending the response, and then we have return equals true. So if we run this again, we get hello world. So now it works, and it works because we actually told our DI our DI where the services are. We told our application what the middleware that it should run and which hook points. We tied everything with the events manager, and everything now is getting a little bit more compact. So that is our routes enumeration and our routes provider. We do have this one here, the not found, and we're going to deal with this in a short while. Before we move a little bit further, I'd like to introduce a couple of more services that will be beneficial for us. The first one will be some error handling, and as well as a logger. So let's add a logger into our application. What I'm going to do here is I'm going to create a folder called storage and then logs, and I want to put a git keep on this one, and what I'm going to do is I'm going to add this git keep and commit it, and then I'm going to put the storage logs folder or the star.log as an exception so that it doesn't go into Git. Alright, and now in the git ignore we need to put storage logs. Just leave that there so that it doesn't keep anything in the storage logs folder. So we don't want anything that is generated here clogging our repository. Alright, so let's go to the container, and remember we had a logger somewhere here. Yep, there it is, a logger. So let's register this thing. Where are we gonna go? There's BCDE. Let's put it here. Self logger. This. All right. Get service logger. Okay. So we want to be a little bit flexible. As such, what we're going to do is log name equals env manager get So we're going to use here the env manager to try and get an entry from our env called log file name, and if that doesn't exist, we're going to use REST-API. This would allow us to come over here in the env and define this if we wanted to. And also I want to be able to define the path. So we're going to do log path equals something like this, but in our case will be storage logs. That's going to be our default. And now we need to figure out what the file will be called. Log file equals env manager app path, and that would be the log path. And then we're missing one of those. Log name and then log. Okay, so we got all those, and then we'll return new service, and that will be a function that we're going to be able to use log name, a log file, and then that will return a new logger, which is the Phalcon logger, log name, and as an adapter will be new stream, and it's this one, log file. That closes, that closes. Alright, so that's our logger right here, the registration. We're introducing the option to define a log file name and log path and the .env. We're calculating the actual the actual path where it's at. This one will be a string as well. And then we're passing those into the anonymous function, and all we do is we're creating a new logger by the name of this, the log name, and then the adapter that we're going to use for that logger will be a stream, so it will write into the file system. So far so good with this, and it is there, but we're not using it, we're not doing anything. So let's do something that would allow us to start using this. And in order for us to do it, we need to create a new provider. We're going to go back and forth a little bit with the Env manager, because here's the plan. We want to create a new provider that would handle the environment. So it would be able to set up the whether you're going to display errors or not, whether you're going to have error reporting or not, and it's going to register an error handler that would allow you to view any errors as well as performance statistics in your log. So we're going to register the error handler as well as a shutdown function in there, and of course after that we can just enhance it the way we want to, right? So this is the plan. In order to do that, we're going to need a couple more methods from the Env manager. So let's find it. And the Env manager needs to return a few more things for us. So we have app path, right? What we need to do is we need to have public static function app and env string, and that one will be self load always. App env equals self get app env, and then we're going to call this development, and then return string append. Let's put the string here. That's okay. It's not the end of the world to have that both. Also, this is the application environment. What we want is also the log level, because we can utilize the log level to do more debugging or less debugging. So log level, and that one would be the same as that, but it will be called app log level, and that one would actually return an integer, not a string, because it's an int. Int, kind of. No, yeah, this one returns either an int or a string. we go. And that one, let's make it, it's 1. And that one will be int log level. All right. Let's do one for the time zone, because we're gonna need it to set up the times. And that will return string. That will be string, 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 and string here. The default will be, actually we have it here, dates. Hold on, hold that thought for a sec. Do we have the dates here? Doesn't seem like it. Question is, where do we put the dates? I want a class that would offer a constants class that would offer me dates and formats to those dates, because I want to use it here and I want to use it throughout the application where we need to. So in this time zone, let me put here, leave that there for a sec, it will be UTC, but should we use domain constants under services? It might as well. Let's put constants here, and what we're gonna do is new class dates. So I already have this file ready. I'm just gonna copy and paste it. It'll save us a little bit of time. So what we do here is we're just saying, all right, I want a date format will be YMD, the now that we can use in database, the data time format, the UTC format, the date time zone. Okay, so this class is gonna allow us to do that, and it also contains this method to UTC that allows us to change the date very quickly. And I think because we're at 8.2, we do have the exception, yes. Simplify and go there. Alright, so with this dates here, the env manager changes to that, and then this date time zone UTC. So this one will allow us to utilize any dates and keep them all in one place, and all that. So I think these changes are enough. We can now start working on our events or our error handle provider. Error handler provider, and what this will do is we just don't need any of this. It will be just the register method. Okay, so let's clean this up. Alright, so what we're gonna do here is we're gonna need to get the logger service, which we just registered before. Get shared, and then again container logger. Now we need to set the time zone. This with env manager app time zone, and now we need to do ini set display errors equals true. Actually, no, we need to do it a little bit different. Errors equals if development equals env manager app env, then that will be either on or off, and that will be errors here. So if we're in development mode, display errors is true. If not, not. Error reporting, all these all can be changed later on. So what we need to do is we need to set error handler, and it's going to be a function of int number, string message, string file, int line, and then that one would use logger, and it would return what it would do is logger, and then it will be an error, and then it would be right. So how are we going to do this? As printf, what would be our format here? But what we need to put is number, line, message, file. So how are we going to present that? Let's do a hash and then %s. That will be my number, and then let's do L for line, the space, and then put the message here, and then in parentheses is the file, and actually it's a %. So it will be the number and then the line that this thing happened, the message, and the file. Okay, and then that one will return true. It's important because otherwise it doesn't work. And also what we need to do is we need to register shutdown function, and that will be on this. Let's call it not handle, on shutdown. And then we need to pass also, hold on a sec, register shutdown. Oh, okay. We're going to do this, and then container will be passed into that. So our protected function on shutdown, which will receive a DI interface container, will return bool, important. So here's how we do this. Register shutdown function, we're just saying call on shutdown and also pass the container in it. Then in our signature here, we're just having the DI container be passed in there. So what we're going to do again is we're going to get the logger here. Get shared logger. That's it. We need time equals, that's interesting. We don't have the time. We need to find the time, the existing time, or the time that it started. Let's put 0 for now. What we're going to do is memory equals memory get usage. Oops. Get you. Oh, come on, really? That. And we have to divide that by, what was it? 6 or 8, 2, 4, 6. I think it's 6. Yes. And then execution equals HR time true minus and then that's more than that. It's either 9 or 10. I think it's 9. Alright, so then in order for us to do everything, we're gonna need if env manager log level is greater or equals to 1. Come on, info, and then as printf, and that will be four, and then number mat memory 2 closes there. Okay, so so we're doing some divisions here for the memory get usage in order to get this in megabytes, and the execution we're dividing it by what is the 1 billion 9 digits or something to get it into seconds. But the main issue that we have is the time. We need to have a measure of when the time starts, when this request starts. So what we're gonna do is we're gonna put this into the container. So let me copy this and then that, and then we're gonna call that timer or time, and then that will be an integer. Alright, so let's go back to the container, oops, here, and create a constant called time. Alright, now we have not defined this yet, but we need to define it at the earliest possible time that we can do that, and the earliest possible time is the index. Where is my index? It's here. So now that we have the router provider and all that stuff, right down here where we're setting the application, we can actually set up the time as well, and the time would be as follows: now equals HR time. We're using HR time for a lot of precision, and it will be container set container time, and it's not now, it will be a function use now, return now, and then true. And it's a little bit convoluted, so let's decipher it a little bit. Come on. Alright, that's better. Okay, so when we start the application, we're creating a container, creating a micro application, dumping the container in it, and then we're storing the application back into the container so we can use it somewhere else. We now also do, we're setting up now, what time is it now? And then in the container time, what we're doing is we're saving this now value, right? And in order for you to save it, you just put it into an anonymous function, and that will return you now. And it is shared, so it will always return this one method, this one value. Coming back to, where were we? To the error handler provider. If you recall, this one is doing some calculations here on shutdown. So what we need to do is we need to make sure that in order for us to have a relatively accurate amount of how much time elapsed since from the beginning until shutdown, we need to have the first time as early as possible and the last time as late as possible. By the way, this one needs to return true in order for it to be complete. So the time has been set in the index.php. We're coming all the way to the end here, and then we're getting that time from the index.php. And then with the execution, we're doing a couple of calculations, and then we're just running it. Well, does that work? Let's have a quick look. It should produce something under logs here, or an error. And it does. The env file does not exist in the specified path. Okay. Alright, the file path is wrong here. Something is going on and the file path is not being passed properly, because the file path should be in our environment here /app, but it's empty. So let's have a quick look. This, of course, we would have found it with more tests, but we're finding it now. So env manager, this. Okay. When we're doing the load here, and when we're getting the options. There it is. So the file path is either app and file path, or it should be self app path. If we don't specify it, it should be the root. So let's run this again. Hello world, yay! And we are getting results back. But let's have a quick look. Did we get the log? No, we did not. And why is that? Because we did not register the provider. This is one provider, this is a second provider. And if you recall again, in the index.php, we have the providers here. We have the router, we don't have the events the error handler provider. So we just added here. And now, if we run this, we're still getting stuff. But if we go back, we're just seeing a REST API log. And if we open the log, you're going to see our code is executing. So it takes 0.64 megabytes and 0.006 seconds, which is great. If you recall, we decided that our payload will always be the same. It will be a JSON payload that will have a specific structure, and all the information that we want will be encapsulated into that payload, along with some methods of verifying the payloads. Case in point, if I print it a little bit, it will be a data node that has the content. It will be an errors node that will contain one or more errors if errors existed, code, hash, message, and timestamp. And the method the class rather that is responsible for doing this is this invoke here. It does all this, but this actually restricts us a little bit because we cannot use this particular methodology or format, if you like, anywhere. We have to come to this JSON responder, and we don't want to do that. We want to be able to send a response from wherever we want, and it will be formatted exactly the way we want to. So what we're going to do is we're going to expand the Phalcon response to meet our needs. Extend, not expand. So let's create a folder here. Let's call it HTTP, and then we're going to call it the class response. Oops. Yeah, well. Okay. And let me copy the doc block here just to make sure that we're fine. Alright. So this response class will need to extend the existing response class from Phalcon. This one, Phalcon response. Alright. What are we going to do here? Alright, for starters, we need to make sure that we have the payload defined in here, because if you recall, let me go back to the JSON responder. What we're doing is we're getting the results from whatever was sent to us from the domain, and then we're creating this payload here with our results, and we're doing some calculations, and then we're sending that payload back like this, like so. We're setting it and sending it back. So in our response class, for starters, we need to have a way to store that payload. Alright, and we're going to leave it like that. We're not going to initialize it or anything. We're going to create an initializer, so to speak. It's going to be the method that will set this array. Actually void, and then it will be this payload, and that one would be data, empty array, errors, and then meta, oops, and then will be another array that will have code. Leave it null for now, hash message, and then timestamp. Alright, so code will be, we'll fix that in a second. Hash will be an empty string. This one message will be okay, or success, or okay, it doesn't matter, and then that one will be an empty array. So that's gonna be that. Now what we need to do is we need to find a way to calculate whatever is going on in here. So from the JSON responder, what we need to do is we need to get this yeah, that should yeah, let's copy this for now. Now let's dump it in here. Alright, we need a way to chain things. Alright, so what we're gonna do is we're gonna say data, well, let's call it payload equals data this payload. We're not gonna call it output anymore. And then that one encoded will be the payload. And then the hash will be, actually we need the timestamp equals dates to UTC. That will give us the current date. Timestamp. The A tag is there. And then what we're gonna do is this payload meta hash equals hash, and then meta timestamp equals timestamp. And then what we need to do is this set content type application JSON, set header e tag equals e tag. Actually it's e dash tag, I think. And then close this here. So this part will calculate the meta for our application. Alright, that's an exception here. Alright, so how are we gonna use this? For starters, we need to have a way of adding data and adding errors if we want to. I'm going to utilize a methodology that PSR uses. It's the with. Now with PSR, whenever you use a with, they clone the object and then they make the change and then they pass the new object back. I don't want to do that. I'm just going to utilize the word with, if it's not a pure with according to PSR, to help me set everything up here. So what we need is we need to be able to set the header, the data, the payload, and stuff like that. So let's do public function with payload data, array data, and that one will return self. And what we need is, if just to make sure, empty this payload, this init payload. This just in case, because we don't have access to the constructor of the response, it's gonna be messy if we do that. We're just doing this little workaround. Whenever our methods are being called, the with payload data and so on and so forth, we're just making sure that we call the init payload if it hasn't been initialized yet. And then this payload, the node is data equals the data. We're gonna this calculate meta and return this. And now with we need to do one for errors as well. So that we're gonna have to come back to this, what it will be. For PHPStan, so a public function with payload errors, array errors, return self, and then we're going to do pretty much the same thing that we did up here. Let's copy that, but we're going to make a slight change. It's not going to be data, it's going to be errors, and then that one will be errors. but also this payload meta, it's not errors, it's code. We're gonna throw a 3000 on this, just stay with me. And then the message will be error. Remember, the message is success usually. So in the init we have success, and the code here is well, actually 200 would be fine. Um, 3000, it's something that we can utilize, or we can use. I don't know, whatever we need. I'm not 100% sure whether this is correct or not, but it's just an arbitrary number. Whenever I see 3000 in the code, I have an error. You can do anything you like in your application as to what the error code or the success code would be. But this is pretty much it. We're gonna set the error, we're gonna set the code and the message. Actually, it's not the error here, it's message. There we go. So that's how we set it up. So we got with payload errors and with payload data. Let's do one with a code as well. With code, and do we really need it? I guess, yeah. That we really need it because I want to be able to chain all this. And if memory serves right, the set status code of the response doesn't. So I don't think that this one returns the array back. Oh, it does. Oh, okay. Anyway, it doesn't matter. We can just leave it there. And finally, we have to figure out a way to calculate this whole thing and just set it up so that when we hit send in the response, it will be sent back. So let's say public function render, and yeah, let's return self for this. So what that will do is it will say this, just in case, calculate meta, and then set JSON content equals this payload, and then done with that, return this. Now here's the interesting part. The calculate meta is done whenever we put the payloads and all that stuff, and it's done with render, so we don't really need it here. We could just save ourselves some cycles of calculation by getting rid of it. And also down here, the set content type application JSON is not really necessary because we're utilizing the set JSON content. We can just leave them here, we don't have to, and since on render we calculate the meta, we can just remove them from here, because the meta will be calculated no matter what before we render everything. And this set content type, we can just dump it out, and that's where we're at. So now we have this response class that has certain things. Let me copy this so that we have all the imports properly done. Okay. And now this response class, we need to make sure that we start using it. So the best way to do it is go to the container, and here that we have the response classes, somewhere here there's a response, which is this one, and then use response I'm picking this one. So now the response will refer to our object and not the Phalcon one, the extended, if you like. So coming back to the JSON responder, this is where that started. We have a date time, timestamp, blah blah blah. We're creating everything here. We have the application JSON, the tag set JSON content. Well, that one is not necessary here anymore. Now the response interface here will require let's see. What we need to do is we need to set the response, right? Response. We need somehow to tell this that this is our response. So this is not response interface, or we're going to change it without the interface, and we're going to call it response, and that will be our response. And you're not going to return this, you're going to return a response. So now that this response is our response, we can call things on it. I'm going to call it down here. Now we have our code working here in the autocomplete. So we're going to do with payload data, and that's going to be this, the content. We have already calculated these things, right? And we've created this. So we know that when we call render, the content type will be set, the header will be set, this one will be set. So we getting rid of that. With payload data is what is that? So payload data expects an array instead of a string. Alright, let's make it an array for now. We can control that later. And then what we're going to do is we're going to call render here and then close this. And what this will do is it sets the payload data to whatever we want it to, and then it calls render, which will calculate hashes, set up the array, set the content into the response, and then the response will be returned. Once the response is returned back, then the response sender middleware will be the one that would just send it back to wherever it came from. Now this is not the Phalcon HTTP response, this one is our response. There you go. And let's redo this. Events exception. Okay. So now, coming back to Mr. Brave, we have a small change. Well, actually, we have no change really. Well, we do. The time stamp is now in UTC because we set it to be that, and code is whatever. And hello world says hello world because it's an array. So what we've done now is we've taken all this chunk of code that existed here in this JSON responder that did calculations and all that stuff, and we put it into the response, and the response will be responsible of sending the correct payload back. And we can utilize now this method here, the invoke, to do other tasks such as restructure the payloads as they're coming back if the result is not properly formatted or the correct one. And remember, we haven't even touched the status code of the result, if it's a success or error and all that. So we're going to utilize those a little bit later. Now, what we can also do is we would like to get a new enumeration going. And I'm contemplating whether I should create a new enumerations folder where I can just dump things in there, at which point the routes enum goes in there. These are the questions that you have to ask whether in your project if you want to be in some sort of a compliance with what structure your team has and so on and so forth. What I'm going to do is I'm going to create an enumeration here under HTTP, and what I'm going to call it is HTTP Enum. That's the class. So HTTP codes enum. And the purpose of this enumeration is to hold different types and different statuses. Now, Phalcon does have a lot of these things. You can utilize them like that. It's entirely up to you. I'm using this as a custom enumeration that would allow us to do a few things in the application. You can certainly scrap this and use the Phalcon ones, or if there's a different implementation out there with descriptions and text and all that stuff, you're more than welcome to use those too. I have it already done, so what I'm going to do is I'm going to copy and paste it just to save time. I know this video is getting a little bit long, so what I have here is I've decided that my regular HTTP codes are okay, bad request not found and unauthorized. I can certainly add more to that. My enumeration is a backed enumeration returning an integer. And then I have some application specific codes, and you see that they start with 3000. That's arbitrary, you can do whatever you want. Malformed payload, records not found, resource not found, unauthorized, invalid arguments. Now, on the text, you see that every single one of them corresponds with a little text. So whenever I access one of these and I call text on it, it will give me the text of the string that returns back. Value would give me the 3400. But what I do also have is error, and you will see where that plays in where we're going to utilize that. The error, what we'll do is we'll return an array element with value as the key and text as the string, the value. So we're going to utilize this especially when we're going into the middleware and how we stop the application from executing. Alright, so now that we have the HTTP codes enum, let's go to the we have OK here, right? Let's go to the response. Where's my, that's 3000. There you go. I can just change this to codes enum. Okay. So now I can use it like this, and then whenever I need to change something, I can change it at any given point. And also for the dates, this UTC here, you don't have to. You can just change the date time format here if you do this, and then you refresh the code and you print it, you're going to see that it comes in this format, not in UTC. So it's entirely up to you how you want to specify how this code will work for you. This is just an example. It's just my interpretation of it. Plenty of room for customization for you. Okay. So right now we have the response, we have the container, we have the JSON responder. We made it less fat, we thinned it down. We have the routes in Enum, we have the responder, enumeration here. We have the responder middleware here. So okay, what else is there left to do? Well, we did get the middleware to work and to respond, but we have one more thing to do before we wrap this thing up. The one thing to do is to figure out what's going on with the 404, and also create one more service, one more service that will say health. All right. So before we go into the middleware, let's create the health service, because we did start on this a little bit in the routes down here, but we haven't done much. So as we have hello here, let's go and make a health. And the health service will be, again, health. This one will be health, and this one will be renamed as health. Alright. So what the health will do is it will return an array that will say I mean, what should we say here? Let's say status, yeah. And I don't need this domain success. Let's say OK. And then message. Let's say service operational. Right? You can just change these to whatever you guys like. This is not obligatory to be like this. So that's my health service. Of course, we need to go and register it in our container, because otherwise we're not going to be able to access it in a way that we want to. So this is the hello service. Let's do the health service. And that's a private const. Where's the hello service here? Health service, and that one will be the health service class. Okay, we do have the class now. That's our domain. Let's make sure that the routes in Enum is pointing to the proper area. So we have a health. There it is. It's going to be the /health URL. There's no suffix. We're fine. As far as method is concerned, it's a get. And we need to define the service here. So for the health get, it will be the health service. So now, if I go back to my browser, yes, I have hello world here. If I do health and pretty print, I have service operational. And this is how easy it becomes to add a new route, to add a new service, and have everything be wired pretty much on the fly. It took us, I don't know, a minute or two to get things going with this. We just copied the class, created the message, went to the container and registered the service, and then all we had to do is just go to the routes and change the service definition, where it's going to be pointing to. All right. So that's fantastic. how we can do that. Finally, we gotta figure out what's going on with the 404 and what is going on with the health as well, and whether we can optimize a little bit the application so that we don't have unnecessary usage of resources. So the first one with the 404 is not that bad as it is defined, but I'd like to make a change so that we can work it out that it attaches as middleware. So right now the 404 as it is, it's attached to the not found method of the application, and clearly, it's just an echo 404. It's not our response. It's not the JSON that we want to send back. So the minute you hit this, you can forget the response sender middleware and all that stuff. What we want to do is, let me just pull up a little text file here. Text. Yeah, it helps if I can type. No, I don't want that. I want this. Alright, so we have request here, goes into index.php and goes application, and then let me just put it like this. So it will boot up the application, and then it will go to action, domain, and then respond. Right, and then it will be, I don't know, echo on screen, something like this. Well, what we want to do is we want to minimize this run on requests that do not need to do all this, and requests that are errors. So a 404 is an error that it didn't find. So the faster we can do this, the faster we can stop it, the better it is. Granted, the current implementation with the attaching to the not found method of micro is actually sitting up here and it's not doing anything, but we're going to utilize a different method which will make sense in order to give you an idea of how you can also utilize the middleware as a 404 mechanism. For what we have is here under application boot, we have middleware, and then that middleware is 1, 2, 3, whatever, right? They run in sequence, and then you have action domain responder, and then a responder has a middleware which is the finish, but we don't worry about that. That's a different thing. We're interested in this sequence here because if we can stop execution at any given point in between 1, 2, and 3, then the rest of our code, the action domain responder, never executed, which means that we have less resources used and less memory and so on and so forth. So let's add the 404 somewhere in here so that it can execute right there. Again, the way we have it, it stops right here, right? We're going to be stopping it here, and there is a reason, and it will make sense. Okay, so for starters, what we need to do is we need to find a way to stop the application. And in order to stop the application, the micro application gives you a method which surprisingly is called stop. So, so what we're going to do is in the middleware, here in the abstract middleware, what we're going to do is we're going to create a method to stop the application whenever we want to. So let's call it halt. And what that would do is it will get the micro application. We need to receive a code. And if you notice, this one follows our payload. Let's make this an empty string. That will be a void. And then in here, what we need to do is we need to gather around the information that was passed, and then make sure that everything is the way it should be. So for starters, we need to get the response. Container response, and that will be our response. Now, first of all, application stop. This one will stop execution of any middleware, anything that goes after. It will not invoke any routes, any action, domain, responder, and all that stuff. Now, if empty, if true equals empty errors. If that is empty, then response with payload data equals data, else response with payload errors equals errors. So now you see why we created those methods, so we can inject whatever we want in it. And now what we have to do is response important render first and then send, because render, our method, is going to calculate all the e tags and whatnot, and it will make everything work the way we want to. We did forget these two, so let's add those two as well. Response with code, and that will be code and then message, and there we go. So now that one is spot on. Now we can use this halt. So now that we have this, let's create a middleware that is going to be called not found middleware. And of course it's going to have the call method, and in the call method what we're going to do is we're just going to return true, nothing else, because we don't need anything here. Actually, this one should return bool, I guess. Yeah. And this one should return bool too. Oops, sorry. Alright. Now for the 404, we need to take advantage of the before not found event, and that one gets triggered whenever a route is not found in the micro application. As the middleware gets processed, if any of them has the before not found method, it will be fired. It will be executed rather. Alright, so we have this before not found, and what we're going to do is we're going to turn false, because if this one executes, that means that the route has not been found. Now, what we're going to do is we're going to say this halt. Remember, we created it. We're going to do this application, and then HTTP codes enum not found value. That's the value of the 404. The message will be error, and then the data will be nothing, and the errors will be HTTP codes enum app resource not found error. I'll explain those in a minute, but first we have to fix this, because the before not found doesn't have access to the application, and in general the middleware doesn't. So we need to find a way to bring this in. We're gonna do a little hack until we find a better way to do it. So in the abstract middleware, what we're gonna do is we're going to extend injectable, and what that will do is it will give us access to the application stuff, and we wouldn't even need to use the micro application here on halt. If it does, then we can just do this application here as well as this response. It's up to who wants to do what. We could use this injectable here, scrap this, and use this response, and that would access our response, as well as this application, which will access our application. I'm just leaving this one here until we find a better way to get rid of the injectable and have access to all the services. But for now, just to demonstrate the not found middleware, this application works here, and we do have the before not found. Now we're gonna have to, we do have this class, which is fine, or this middleware, but we're gonna have to enable it. To enable this middleware, we have to do a few things. First of all, we need to go to the routes enum, and we need to add it here, but in order to add it here, we have to go to the container first and add it as a service. So we're gonna add middleware not found, we're going to set it here as a service, as the service, and our class will be not found middleware class. So now it's registered in the DI container. Back to the routes enum, we're gonna have a not found, and that would be an event before. So it's gonna execute before any routing happens, before anything happens to our application. So this one will execute before anything goes astray. So let's have a quick look. What do we have here? So we have, let's say here, unknown. It still gives me this 404 not found, just a simple echo, and it's obvious because we still have this code here. So if we remove it and we make sure that the events manager is available in the application, this is one step that I forgot to do. So application set events manager equals events manager. So what we're doing is we're getting one brand new events manager, we're setting the routes, and then when we attach the middleware here, if you recall, we're doing this line. So we're attaching the events manager to the micro hook and the relevant instance that needs to be attached, but then we have to notify the application that you need to use this events manager, the one that we created. Once we do that, then we see totally different things here. We see resource not found, and this thing executed. And if you want to confirm that this is executed, what we're going to do is we're going to go back to the not found middleware, and instead of using the application source not found, let's say we put unauthorized. And now if we go back to the browser, we should see unauthorized here. There you go, is the preprint. So that particular piece of code executed just fine. We're just gonna remove this. So now what we have done is we have removed this not found completely, and we're handling the 404 plus the response sender with middleware. One is before and one is after. We still have something that I mentioned a little bit ago. We wanted to get this application here, and we had to go to the abstract middleware to extend the injectable. That was a little bit of a brain fart on my part. We don't really need to extend the injectable. All we have to do is modify the signature of the before not found, and the signature is event and then micro application, because the mechanism of calling this event will always inject the event as the first parameter and then the source as the second parameter. So if I go and run this again, you see I'm gonna see resource not found, and the numbers will keep on moving, meaning that it does execute. So that is great. We started using the middleware that Phalcon provides, and we're working on this layered approach that I mentioned earlier, so that each middleware works, and once it executes and it's fine, then it keeps on going to the second one, third one, fourth one, however many we have, and then it goes and touches the routes. Otherwise, if it fails, it actually stops right there. It works a little bit like Shrek with the onions. You have layers, so it stops everything in a layered environment. So one last thing to do, since we want to do that, is to actually move the health service into a middleware, because health is health right now is an action, and then it goes and picks up the domain service, and then it does the response. So it's the full cycle going back, but we don't really need to do that full cycle. If our web server cannot serve any responses, then the service is down. If you've touched middleware, the application has booted up. Anything else is extra. So if we add the health to a middleware, then it will be able to respond perhaps after the not found. It will be able to respond on the second step, if you like, on the second layer of the onion, before instead of going all the way into the responder. What we are going to do is we're going to create a health middleware. So let's take our not found and just copy it. All right. We don't need this before not found. Let's copy this piece of code here. And now we have to figure out whether this request is a health request. Okay, so for starters, because it has to execute only if this is a health request, otherwise it has to let everything go to the next middleware. Request equals application get shared service. That's our request, and it's of type request. There you go. And then we need to put if health get URI and true equals request is get. So now the payload will be status okay, and message will be service okay. So now what we need to do is we need to call halt again, and it will be an OK, and that one will be HTTP codes enum OK text, and this one will be payload, and we don't need anything else. And that should halt the application running right there. And actually if you look here in the, we have service operational, right? That comes from the route, the action. I'm gonna put a few exclamation points just to make sure that this is being hit and it works just fine. So let's go here to the routes enum. First we need to go to the container, and we're going to say middleware health. Actually this needs to be above it because H is before that. Middleware health. We're registering the service, the class. Health middleware class. And now we need to register it as a middleware, and we're going to register right below the not found. Or actually, let's put it above. Okay, so if we run it now, you see we got 3 exclamation points. Now look at this difference. If I move this middleware below the not found, it is going to work. But it works because we have a route defined. This route exists and it is defined. So if I remove this route completely, so there's no middleware health, there's nothing, and now when I refresh my page, you see resource not found. If I come and move it above, the health being first, and I refresh my page again, it says resource not found. So it doesn't really matter where you have it. It will the resource is not going to be found because we don't have that particular route defined. Okay. So now we're going to use a small trick that will pretty much tell Phalcon that this is an actual route, but it's not a route per se. So it's a route that will allow it to go to the middleware and execute without being a route that will go to an action and execute. To do that, we have to trick the application. So let's go to our route provider, and here where you see attach routes, attach middleware, what we're going to do is, we know that this is a get, and we know that it tries to get to the /health, right? So let's do application get, and that will be /health, and then that will end up with a function of nothing. So in this instance, what we're saying is that whenever you see a health, it doesn't do anything. It's not going to be executing anything. We're going to put that so that it doesn't complain. But by doing this, we've actually registered this route. So now if I go back and I refresh, you see that it says service operational. It's the 3 exclamation points. And to further prove the point, I can delete the health service here and go to the container and get rid of the health service, or the health service constant. So this is a little trick that allows you to utilize the middleware and perform a task, albeit a small one, but you're still letting the application work, because if the /health does not exist in your application, the 404 is gonna trigger. But if you go to the router provider and just say, create a blank route, then the application will say, okay, this route is a valid route, it has been matched, so start running the middleware. And then once it starts running the middleware, it will end up to this one, the health one. It will run whatever it needs to run, and then it would stop. It would not run anymore. So it will stop at the let me see, what do we have here? Let's put the 404 first. It will stop at the second middleware running and will not execute anything else. So that's all I have for today. Good progress. Next one, we're gonna concentrate a lot on tests and PHPStan as well. And then I don't know if we're gonna have time. We're gonna start working on users, how we can get a user, how we can add a user, and so on and so forth. And that will give you an idea of how you can get your data and send it back. So yeah, great progress in this one. We managed to do a lot of things with PHPStan, routes. We enabled the logger. We put an error handler in there. Additional methods to the event manager. We created our own HTTP response. And we enabled the middleware. Thank you so much, and hope to see you soon.